Good morning, Shem Stars. In previous video of this chapter, gravitation, we discussed about the gravity and universal law of gravitation. In this presentation, we will discuss free fall and acceleration due to gravity. We know because of gravitational force, the earth attracts every object towards it. So when an object falls towards earth, it happens so because of the influence of gravitational force. When only the gravitational force acts on the object during its free fall, then this motion of object can be called the free fall motion. During a free fall, the direction of motion of the falling object remains unchanged. But due to the Earth's attraction, there will be a change in the magnitude of the velocity. Whenever an object falls freely towards the Earth, an acceleration is involved. As the acceleration is due to the force of gravity, the acceleration of freely falling object is called the acceleration due to gravity. Acceleration due to gravity is denoted by the symbol g, that is small g. The unit of acceleration due to gravity g is the same as that of acceleration. So, SI unit of g is meter per second square. We know that force of gravity acting on an object of mass m just near the surface of the earth is given as shown in this formula of the slide. F is equal to g product of two masses divided by r square, where me is the mass of the earth and r is its radius. In accordance with the second law of motion, force of gravity on an object must be equal to the product of mass of the object and acceleration due to gravity. So it will be F is equal to mg. Now replacing the F with mg is equal to gm mass of the earth upon re square. Or we can write g, small g, that is acceleration due to gravity, depends upon the mass and the radius of the earth but is independent of the mass of a falling object. Thus, the value of g is exactly same for all objects, whether they are big or small, solid or hollow, at a given place. Let's calculate the value of g. To calculate the value of g on the surface of the earth, let us put the values of g, that is universal constant, mass of the earth and the radius of the earth in the equation. We know that the mass of the earth m is equal to 6 into 10 to the power 24 kilogram. Radius of the earth is, that is r, 6.4 10 to the power 6 meter. And the value of gravitational constant is fixed, that is 6.7 10 to the power minus 11 Newton meter square per kilogram square. On substituting these values in equation, we get 9.81 meter per second square, or we can write 9.8 meter per second square. This is the value of acceleration due to gravity of the earth. So children, this is all about free fall and acceleration due to gravity. I hope you must have understood. In the next presentation, we will talk about motion of objects under the influence of gravity. Thank you, Shem Stars. That's all for today. You can drop your queries on Google Classroom. Take care.